In this cast, I'm going to discuss about the effect of a slider on a curve. Remember, when we are drawing a curve, it has the coefficient of x squared, the coefficient of x, and then the constant. I'm going to use the three constants and show how we can use the slider to make uh, to make the different kind of situations that can occur on a graph. Step number one is that we have to create sliders. So the sliders that we have to create slider. Slider is found here. Create the three sliders. That is slider. The first slider here, I'm going to call it A. I'm going to call it A, and then it is a number. Then -5 to 5 is okay to me, and then give it an increment of 1, so it will be increasing by 1. So that is the first slider, and when you get the slider, it moves from the -5 that you've picked to 5. You can see my slider. Pick a slider B. Slider B, it is B here. It's a number. -5 to 5 is okay to me, and then an increment of 1, which is okay. Then you create the second slider. Bring it down a bit. And then bring slider for the constant now, which is our slider C. C is here. It's a number. -5 to 5 is okay to me. Then an increment of 1 is good to me. So I have now the three sliders. I have the sliders A, B, and C. So these sliders now have to be connected to the function that you're going to write here. So what is our function? Our function, I'm going to use a function, a vertex function. Y is equals to vertex function, which is, let me just use y is equals to, so that I can have the connection. A is the first constant. Then we have x minus b. So b is our second constant. Then we know that in when we have a vertex equation, then x minus 1 is squared here. So we square it. So let me square it here. So let me bring this. Let me square this. So I can square that. Then plus a constant c. So when you reach there, then you have a vertex equation. This is a vertex equation, or a function that is in a vertex form of a quadratic function. So then you enter. So when you enter, what happens? You find that the curve is drawn. You find that the curve is drawn, and it is facing downwards. Now, you'll find that A, B, and C have taken these values of the sliders. A is -1, B is 1, and C is 1. As you can see here, they have taken the place of the constants that you have here. So there is a connection between this equation, this function that we have here, and the sliders for the values of A, B, and C. Now let's start with, if you are starting, let's start with when A is equals to 1, and B is equals to 1, and C is equals to 1. Then what happens? Look at the exploration part. When you're dealing with this particular topic, the way the students have to get the facts, the experience, and of the changes that we have in A, B, and C. So if I start changing, now look at our vertex equation here. Let me start changing A. A is equals to 1. They are all 1, 1, 1. What happens when A is changed? Now look at where A is. Let us change A. So let's take it to 2. So what has happened? Look at the curve. The curve was here when it is 1, when it is now 2, when it is 3, when it is 4, when it is 5. What is happening to the curve? Move back. When it is 3, when it is 2, when it is 1, when it is 0. When A is 0, you can see that it forms a straight line because Y is equals to C, because this one becomes 0. Also, where is the curve facing? It is facing upwards. When it is at 0, is there. When it is now negative 1, you can see that the curve has changed its direction. So the student has to learn then, when the values of x here, the coefficient of x squared is negative, then the curve changes its direction downwards. So then when we increase the values of A to the negative part, what happens to the curve? What happens to the curve? The curve becomes narrower. When you move towards 0, what happens? The curve becomes bigger. So it means that as you move towards 0, the curve becomes wider. This is some of the discoveries that the students have to make. Now, if we go to B, see where B is. Now, if we go to B and make an adjustment and move when B is equals to 2, and even check the coordinates and the behavior of the curve, B is equals to 3. See the way it's moving. B is equals to 4. Look at the way the curve is behaving. Look at this transformation. Then move back. Look at the way the curve is behaving. Look at the way the curve is behaving. Negative 1. So, what is the inquiry point here? You can see that B is equals to negative 1. And then the value of x here is negative 1. What is the value of y at this point? Y remains to be 1. You can see y remains to be 1. So as you move, what happens? What happens? What happens? So then the question is, what type of transformation is this when we affect the value of B? That is where discovery is. Engage the learners, let them explore. When we move to point C, the constant C, we want to see how it affects the curve. Look at C. The curve is moving up. The curve is moving up. C is equals to 4. Look at where it is. Look at the value there. C is equals to 3. Look at the value of y. Let us move. Let us move. Let us move. Let us move to the negative 1. C is equals to negative 1. You can see the beauty. You can see the beauty of using GeoGebra in teaching about the effect of the values of A, B, and C on the curve. And the student can easily get the transformation of the effect of each one of them. Therefore, I urge my colleagues that this is an area that we need to venture on. So sliders are very key. This is only part of the areas that we are using sliders, but we are going to discuss more and more in other particular areas. Thank you.